Blake, so we're good anytime. All right, hey, thanks everybody for coming today. So come in. Oh, okay. All right, so thanks everybody for coming for today's Distinguished Speaker Series speaker. Today's speaker is Marcus Crede. Marcus is an associate professor of psychology at Iowa State University, and he's also the director of the quantitative certificate program, and you'll see his quantitative skills on display, no doubt, a little bit later today. Prior to Iowa State, Marcus was also a professor at Farley Dickinson University, University of Albany, and George Washington University. He received his PhD in Iowa psychology from the University of Illinois. He also has a BS and MS in business science from the University of Cape Town. Marcus was actually born in Germany and then did most of his schooling in South Africa, and then sometime in his 20s left South Africa for the University of Illinois to do his PhD work. He has had grant funding from the United States Army and done a number of projects with the U.S. Army. He is a reviewer at pretty much every top journal in IO psychology and personality psychology. He's on the editorial board at Personnel Assessment and Decisions, Human Performance, and Motivation Science. He has more than 50 publications on the topics of leadership, management, personality, emotional intelligence, academic performance, job satisfaction, and job performance, among several others. Many of these are meta-analyses, which some of you may not be familiar, but meta-analysis is where you're combining the results of many, many studies to try to draw conclusive evidence about a particular field or a particular topic. He has more than 6,400 citations, which is really a huge number considering the number of publications, right? If you think about the number of publications, right, the citation rate is really high. So when Marcus publishes stuff, people really cite it. His H index is 27. One of his meta-analyses is on the topic of grit. I'm sure he'll mention it in today's talk. It was just published in 2017, and it already has more than 500 citations, which is really a tremendous rate. And that paper also received the PsyOp Joyce and Robert Hogan Award for Applied Research in Personality Psychology in 2019? 18 or 19?
18, I think. It was 18.
I think it was for 18, it was awarded in 19.
That's right.
And so again, he'll probably mention that today as well. So we are a big fan of Marcus, and we're really excited to have him here today. Thank you, Marcus.
Well, thank you. Thanks for the welcome. I'll start out by saying that most of those citations are from miscitations. I think we've looked at one of our papers that's been cited 500 times, and I think 95% of them are wrong. So it's always a little bit sobering. But yeah, thanks for the welcome. I'm going to start out by saying that I took some risks coming here. I got on 2 airplanes, and I drove through a snowstorm, and I parked my car in a public place, and I had two wonderful meals with folks here. And those were obviously very low-risk events, but I think people would have forgiven me if I hadn't come here. If I'd gotten on the plane and the pilot had said there's a 5% chance that the plane will crash, I may not have gone out for dinner with Robert if I'd been told there was a 20% chance of me getting food poisoning. And so I think we live our lives and we accept certain very low base rate risks as part of life, and we live our lives accordingly. But sometimes I think the risk of something bad happening gets so high that we reasonably avoid engaging in certain behaviors. And I've, over many years now, arrived at this conclusion that I think it's relatively safe and perhaps even prudent to ignore much of what's written in modern I/O and management journals for reasons that I want to explain to you today. And I've arrived there through a somewhat circuitous route. I'm not the only person to have kind of written about these kind of issues, so I'll acknowledge some other people who've talked about problems in the field and how prevalent they are. Jeff Edwards has a wonderful paper in which he reviewed everything that had been written in the Academy of Management Review, kind of the leading theoretical journal in management. And he noted, him and his co-authors, that all the theories proposed there were never tested. They couldn't find a single actual test of theories that had been proposed. Jose Cortina looked at models that people claimed to have tested, often using structural equation modeling in the management field, and he found that 47% of the models that actually were tested were not the ones that people claim to have tested. So there was this kind of mismatch between claims and reality. Boiled this wonderful paper, very depressing, on what he called the Chrysalis Effect, which is the wonderful transformation that happens when dissertations become journal articles. Hypotheses are added, hypotheses get left out, variables change magically, things that are significant were not significant suddenly become significant. And again, very widespread practice. We're toying with the idea of doing something similar in social psychology. McDaniel has a wonderful paper on how widespread harking is. Harking is hypothesizing after results known. You look at your data, and then you decide what the hypotheses were, and you pretend like you had them all along, and he was able to show that that was very prevalent in psychology. And then John et al. Did a wonderful paper in which he asked people to self-report, self-disclose all sorts of questionable research practices, everything from kind of the very worst of outright data fabrication all the way to some of the more milder stuff, like you don't report some of the dependent variables that you actually measure. And for some of them, the estimates were almost 100%, especially for some of the milder ones. But even data fabrication, he estimates about 15% of all researchers engage in outright data fabrication. And for me, if it is 15%, that to me gets to the threshold where I can't trust anything that I read anymore. So we certainly have widespread problems as documented by other people. We also have, I think, relatively poor training in methods and statistics. Graduate students often get 1 or 2 semesters in this, and then they kind of forget most of it and do their research the way they always have been trained to do it before. And we also have, especially in the management field, ridiculously large financial incentives for engaging in these practices. Business school professors make often well over $100,000 a year. There are often these unacknowledged bounties for publishing in certain journals. You get something in the Academy of Management journal, suddenly magically you have summer funding for the next 3 years from your dean. And those incentives obviously, I think, distort the kind of research that people put out. My own work in this area has led me to some other conclusions. First of all, we have almost no evidence of open science practices in this field. So we like to make fun of social psychology and personality psychology for some of these very questionable practices that happened in the past. But they're making a real effort to reform, right? We see more and more journal articles where hypotheses were pre-registered, where people present their data, where people even acknowledge ahead of time or outline how they will analyze their data. We don't see any of that really in IO psychology, outside of perhaps 2 journals. I'd say Leadership Quarterly is doing a decent job in that respect, and the Journal of Business and Psychology is also making some strides there. But most of the top leading journals where management scholars really want to publish, there's none of that happening here. We did a recent review of the journal's Applied Psychology, the 2019 volume. We found 1 article that had a direct replication attempt, so nobody's really doing replications. That same article was also the only one that had a pre-registered hypothesis. So again, the potential for harking is vast. And 1 article, again, the same one that told people ahead of time how they would analyze their data. And there were only 9 articles out of about 77 that reported their data. And almost all of those were meta-analyses, where people simply had a table of here are all the effects that we coded, which is not typically what we think of. It's nice, but it's not what we typically think of in terms of open science practices. So as a field, and this is still the gold standard journal in IO psychology, we're really very, very far behind what are considered sound practices in other areas of psychology. We also have, I think journal practices are lagging behind you as well. Nobody's requiring open science practices. There's no journal that says you have to submit your data, even though that's increasingly common in other disciplines. There's a general unwillingness to correct the academic record. I have personally flagged dozens of papers with journal editors, and almost all of them simply turn a blind eye. And some of the things that I've been told is things like, well, if we retract this erroneous paper, we will get sued, so we really can't do it. Or another favorite of mine was, well, if we retract or correct this paper, then we have to retract or correct about half of all the other papers we've published over the last 10 years. So there's a real reluctance on the part of journal editors to get involved. We don't reward replication attempts either. It's not something that gets you tenure, that gets you awards, that gets you published. And there's this overriding emphasis on theory. Right? Theory, every article has to make a theoretical contribution. Nobody's ever allowed to test a previous theory or simply say, here's some really interesting, cool data, even though we don't really know what it means right now. We've done everything right on the design front. So I think all of these things kind of together combine to produce a field that's increasingly struggling to kind of remain relevant. For me personally, this weird journey started with an email from Peter Harms. Some of you know him. We sent me an email, and I managed to track it down. It was the 14th of November, 2011, so it's been almost 9 years now. And he said, Marcus, look at this correlation table. And I should never open the attachment. Because what he was, and his initial interest was simply very simple. It was this correlation table published in a paper in Leadership Quarterly, and he was concerned with that correlation of 0.99 between two variables in the bottom there, the last two variables. And he was simply like, is that possible? Is that weird? And of course it's weird. I guess it's possible with sampling error you can get weird correlations. But I started to take a look at the rest of the paper. And this was a paper that had this kind of path analysis, structural equation modeling analysis. And they tested this model that you see here, and you don't have to worry about the details of it. At the bottom are some fit indices that often people get excited about, right? The CFI is good, and the RMSEA is appropriately low. And I looked at this, and I soon realized that almost everything written in that table was impossible. Almost everything is wrong there. Just to walk you through some of those errors. First of all, the fit of the model is much, much worse than what's actually reported here. You can take that correlation matrix, if I go back 2 slides, and rerun that path model, right? You can use that information to run the same path model, and you get fit that's much, much worse than what's reported. The degrees of freedom were wrong, right? They shouldn't have been 16, they were supposed to be 27. So somehow 11 paths got magically added that nobody disclosed. The authors claimed that adding more paths made the model worse, which again, not possible, right? Adding paths will make the model always fit better. And basically all of the fit indices that they reported, these global fit indices with the wonderful acronyms, were also not consistent with each other. For example, RMSEA is simply a function of sample size, chi-square, and degrees of freedom. If I know those 3 numbers, I can tell you what the RMSEA is, and it's not supposed to be 0.08. It's supposed to be like 0.27, right? Which is terrible, terrible fit. So the authors here clearly kind of lied about what they had found. And that's one paper, perhaps an innocent error. And so I started working through other work by these authors, and I found 28 papers that had similar errors. And I contacted the authors, and they said, well, no, we didn't make any mistakes. So I went to the editors, and 2 of them at Leadership Quarterly and Journal of, what was the other one? Journal of Organizational Behavior retracted the papers pretty immediately. Within weeks, they had said, this is clearly wrong. The other journals all turned a blind eye. So I certainly learned my lesson there about what to do. And there were various types of errors that we identified here. And it was really kind of stuff that was startling. And one of the interactions we had with these authors was when I pointed these errors out, they came back to me and said, Marcus, you're right, but everybody else is doing this too. Why are you coming after us? And so I couldn't believe it. I was like, no, there's no way everybody else is doing this too. You're like really bad actors here. There's no way this is really happening. And so what we ended up doing is we reviewed 155 articles in 3 of our top tier journals, just to see whether they were right. Was this really happening? And we focused specifically on articles that reported confirmatory factor analysis, very popular in this field, to kind of, as part of your manuscript, to do some CFA analysis. We found 56 articles across these 3 journals, just from 1 year. And so it's a snapshot to see what was going on. And what we looked for was whether similar inconsistencies were present there as well. And we really were I was basically gathering ammunition for this editor to say, you're the only people who are doing this. This isn't happening anywhere else. You can imagine where this goes. 57% of these papers reported degrees of freedom that were not compatible with the models they were describing. That was one of the errors we had flagged in these 28 papers. So it's kind of a big deal. 21% reported degree of freedom differences that were inconsistent between nested models. So when people do model comparisons, is model A better than model B, they often use the degree of freedom difference there. And again, those didn't match up. 29% reported no tests of alternative models whatsoever, which is simply a bad practice, right? You should always compare your theoretical model to something perhaps more complicated, perhaps simpler, to see if it really holds up. And there were all sorts of other errors that were of greater or lesser severity depending on how you look at it. But the second last one is kind of startling. Basically, 16% reported inconsistent fit indices, where you have 2 models and they're reporting a CFI value, for example, for both models, and they cannot both be true. And they're often wildly off, right? You can compute whether they're consistent or not using basic high school algebra. And we approached some of these authors after the fact, and once again, the editors don't care. The authors typically don't respond to emails pointing out these errors. So this was kind of one of the first things where we became a little bit alarmed. Another thing we did was we started to take a look at a particular subcategory of constructs in higher psychology. And these are what we refer to as higher order constructs. And they've become remarkably popular in management to propose a new construct, a new variable, that's typically an aggregation of other constructs. And a really good example of that is perhaps core self-evaluations. Core self-evaluations was proposed in the early 2000s. It's supposedly a combination of locus of control, neuroticism, generalized self-efficacy, and self-esteem. Right? That there's this overlying, overarching component which they call core self-evaluations. In the leadership field, we see things like positive psychological capital and authentic leadership, also both higher order constructs that have been proposed. And so we specifically took a look at how had those been tested, how had these been established. And often they're foundational documents, right? These are not papers that are cited once or twice. These often are accruing hundreds, if not thousands, of citations every year. Authentic leadership, for example, has like 3,000 citations already. So here's one example of this, how this is structured. So there are supposedly 16 questions that measure authentic leadership, 4 subcomponents, and then this overarching authentic leadership factor. And again, the authors here present some nice fit statistics, and most readers look at that and go, yay, that's a really good fit, looks like they're supporting it. They also did something else. They do test an alternative model where these 4 factors are simply kept separate, right? They're 4 distinct things. They may be correlated with each other to some degree, and they present the fit of that as well. And what they say is, I'm going to flip back and forth here, is that this model here has worse fit than that model there, therefore we should accept this higher order model. The problem with that is that this model cannot have better fit than that model. Right? It is a simpler representation of the data than this model. So the chi-square, for example, always has to be higher for this model. It cannot mathematically be lower. Also, all of those other fit statistics up there are incorrect as well. The degrees of freedom are wrong, the CFI values are wrong, the RMSEA values are wrong. And again, this is the focus of the entire paper, right? This paper led to the conclusion that authentic leadership is this overarching thing that we should be interested in studying, and that we can measure it with these 16 items that they proposed. So again, contacted the authors, contacted the editors. We get a letter in the mail telling us to cease and desist from the lawyers, and that the paper is still out there. And of course, that was just one example. Core self-evaluations, similar kind of issues when you look at the foundational documents. These impossible, implausible results. Positive psychological capital, proposed by Fred Luthans, which is supposedly a composite or a combination of optimism, self-efficacy, hope, and resiliency. They never tested the most plausible alternative model. Basically what we did, we looked through 25 years of research in this field of articles that had proposed and tested these higher order models, and we couldn't find a single one that had been tested appropriately. And each one of these, almost inevitably, there were a couple of exceptions. Most of these papers cited hundreds of times, and really foundations for entire research subdisciplines that emerged from them. So for us, that was kind of obviously of concern. This is obviously another higher order construct that some of you are more familiar with. This is the idea of that grit exists as a higher order construct with 2 subcomponents, perseverance of effort and consistency. That should be consistency of interests. And Angela Duckworth published this in a 2009 paper with Quinn. And again, the problem here, of course, is that the alternative to that model is one where you simply keep these 2 factors separate, right? You can study perseverance as an individual variable, and you can study consistency of interest as an individual variable. Is there a need to combine them? They're probably correlated to some degree here. You think of that as some number C, the correlation between those 2 variables. The problem here is that if you're trying to model this, if you're trying to fit grit as a higher order factor, you basically have 2 paths, A and B. And A times B fundamentally has to equal to C. Right? A times B models the relationship between C. Now those of you who remember your high school math will probably recognize that there's an infinite number of solutions for A times B equal to C. Right? So there is no unique solution, and yet they present one in their paper. So the question is, well, how on earth did they do that? And the only thing they could have done is to say it has to be equal to B. The only way you can get this, what we call identified, is to make the 2 paths equal. But if the 2 paths are equal, then this model is the same as that model. Right? You're basically modeling it through one path. And if you're showing that that model has better fit than a model that is simply a single factor model, which is what they did, then really what they showed in their paper is not that grit is a higher order construct that we should pay attention to. What they actually showed was that grit doesn't exist, that there are two separate factors that we should not combine. So ironically, they showed the exact opposite of what they had intended to show. And I just last week, it's been about 10 days I think, I emailed Angela Duckworth finally and said, can you please correct this error in your work? She says that she'll get to it right away, and we'll see what happens. She's known about it for about, when did the paper come out? 2016, I think it was up online. So she's known about it for about 3 years, but she hasn't corrected her work. So again, it's for me a somewhat problematic construct. And of course, we have a couple other ones. Another favorite of mine is collective intelligence, which made a huge splash, published in Science in 2010. And the idea here is that in much the same way that there is a theoretical general intelligence factor underpinning performance for individuals, you can do the same for groups, right? That groups have a collective intelligence variable that describes how well they're going to do on various tasks. And it was really a revolutionary claim. If you speak to group and team researchers, up until that point, they'd all believed that a group that's good at one thing, for example, a production task, might be very bad at another task, like an innovation task. Right, that these are competencies and skills that are required that are quite distinct. And what these authors claimed to have shown was, no, there's a single underlying component, a single collective intelligence factor that underpins performance on a wide range of tasks. And what they did was they did some fact analysis of group performance tasks. They basically had a couple of hundred groups, gave them a whole series of tasks, and then did a fact analysis. So for their foundational paper, these were, I think, 10 different tasks that these groups were asked to do. Everything from a brainstorming task to reproducing an artwork, so really a nice variety of tasks. And what they found was, using exploratory fact analysis and confirmatory fact analysis, that their claim that there's a single factor, and that basically indicates evidence for collective intelligence. Now, it's one of these weird cases as well, where I feel like the original authors had never done fact analysis before, and it turns out when I reviewed their videos that was actually the case. Because you can try to factor analyze other data, and you will also get a single factor coming out of it. So here, hypothetical data, 8 different group tasks, and what you see, if you look closely, and that may be difficult to see, is that the first 4 group tasks, there's a relatively strong correlation between how well you do on one task versus the second, third, and fourth task. But tasks 5, 6, and 7 are largely uncorrelated with each other and with all other tasks as well. If you do a factor analysis of this correlation matrix, you will get a single factor. If you do a confirmatory factor analysis, you will get a single factor. But it doesn't mean that there is an overall factor underpinning this data. Because basically what can happen is that the one factor that exists underlies these 4 tasks, but not the other ones. The other ones are basically completely unrelated to the general factor. And that's what happened here as well. If you do a factor analysis of their data, you see that the loadings are often quite low for many of their tasks. For example, moral reasoning, the loading is 0.11. Right? So if I look at that, I would say, well, moral reasoning is not really explained by this general intelligence factor. It only explains about 1% of the variance. Brainstorming, matrix reasoning, those are perhaps relatively similar, but moral reasoning, planning a trip also seems to be quite different. The loading of 0.23 doesn't seem to really fit in there. The estimation task, loading of 0.32, the reproducing art, 0.34. These are not loadings that we would typically associate with a strong general factor. And there were some other sort of startling problems with this. For example, I think they had 152 groups in their initial paper that had done these different tasks. And the brainstorming task is a nice example of this. So the brainstorming task, these were groups of 4 or 5 who sat around a table. They were given the task of coming up with as many uses for a brick as they possibly could. 10 minutes to do this, 4 people. There were groups who scored 0 on that. And they were given points no matter how idiotic the use. There was no judgment of quality. Like if you said, I can use a brick to build a house, that would be a point. As a paperweight, that would be a point. So there were groups there, at least one, we don't know how many, who scored 0 on that. And you might think, hold on, that's really weird, what's going on here? It's probably because they weren't engaged with the task. They didn't care. Or there was some sort of data collection error. But if you see a score of 0 on a task like that, it should give you pause. You shouldn't necessarily include that in your data. Same with the Ravens progressive matrices, right? They were asked, again, we given like half an hour to solve as many of these as they could, and there were groups who scored 0. And some of the Ravens progressive matrices are relatively straightforward to solve, especially in a group setting. The moral reasoning task, again, groups scored 0. The Wonderlic scores were really bizarrely distributed. There were groups on the Wonderlic. I'm not sure if people are familiar with the Wonderlic. The average is around 21, I think, is the population average. There were groups of 4 where the average Wonderlic score was 8. Now, obviously, an individual can get a score of 8. That's relatively normal. But for 4 people to have an average score of 8 is almost impossible. Right? Unless, again, they're not trying at all. They're not engaged with the task. And if you have that kind of data, those kind of scores in a factor analysis model, you can end up with really artifactual findings, as I'm going to show you right now. And this gets me, we'll get back to that in a second. This ties in with the last thing that is kind of hot off the presses for us. This was literally some data that just reached me from one of my collaborators a couple of days ago. We were interested in this issue of careless, low-effort responding also to survey questions. And specifically, we started getting interested in whether a lot of the moderation analysis that's reported in this field is simply an artifact. Moderation analysis is very popular in this field. These are from 2013 to 2018. We did a quick review of what proportion of articles reported moderation results as a focus of their papers. And you can see it varies a little bit across journal articles. Journal of Applied Psychology, almost 30% of articles focus on a moderation hypothesis. That's like the focus of the paper. JPSP is a little bit lower. It's only about 18%. Probably varies a little bit by subdiscipline. But it certainly is a relatively prevalent area of inquiry. And so when you look at moderation analyses, you know that those of you who've tried this, they can be really, really tricky to find. And there's lots of reasons for that are largely statistical. That interaction term that you form by multiplying the independent variable and the moderator term tends to have really strange distributions, especially when the 2 components are normally distributed. They get very peaked. Interaction terms have often have terrible reliability, because again, the reliability of an interaction term is the product of the 2 reliabilities. And then also, if you're thinking in terms of IRT terms, the moderation requires you to have really good information at the extremes, at the low and at the end, at the high end. Most tests that we use in standard research practices, the test information function is peaked towards the middle of theta, not at the ends. And so we have some really problematic issues to deal with when we do this kind of research. We also have the problem that samples are very difficult to obtain in organizations. As an organizational researcher, if I go to an organization and say, I'd like to send out a survey to 500 of your employees, it's almost impossible to get permission for that as a researcher. So our samples, they're difficult to obtain. They're often relatively small. If we do obtain them, the amount of time we get with them is relatively low, and that obviously results in worse measurement. Employees are rushed, or they are not engaged with it. They say, I have to do this at home. I've got to fill out the stupid survey, or I've got to put my work aside to do this work for this researcher. And so we often, I think, have some problems with kind of random and careless responding. I revisited an old data set of mine. We had data from 1,000 employees, and about 40% of them could not be distinguished from random data. They kind of just went through it and basically filled it out as quickly as possible so that they get back to more important things. And some researchers, of course, rely heavily on MTurk these days. You pay online researchers, online workers 10 cents to fill out 500 items, and you can imagine the kind of quality that you get. One of my favorite studies, published a year or 2 ago in the Journal of Applied Psychology, claimed to be based on a sample of executives, CEOs of companies. They gathered this data through MTurk, and they paid these CEOs, I believe it was 50 cents to complete a survey, and it had to be done on a Sunday evening or Sunday afternoon. I can't imagine any CEO sitting around an MTurk on a Sunday evening filling out surveys for 50 cents. But somehow this got through the review process. So whatever data we're getting, I don't think it's of the quality that we really need. So we have this problem that random responding occurs to a fairly high proportion in many of our participant pools. I speak regularly to my graduate students in my department and ask them, if you include attention checks, what proportion do you have to throw out? And the typical answer is between 20 and 30%. That's when you include an attention check item, which many researchers, of course, do not. Employee participants in MTurk workers have probably even higher base rates of that. And the problem with that is that that can actually dramatically inflate your effect size estimates or correlations, and I'm going to quickly show you how that happens. So imagine that you have two variables y and x, and you have some random responders in your data. And because of central limit theorem, if people are randomly responding to Likert scale items, their aggregate will cluster towards the middle, right? And so these people will appear to be relatively towards the middle of however you're measuring y and however you're measuring x. So those are our random responders. I can add in some non-random responders, right? These are people paying attention, again, distributed at all levels of y and x. And if I add in the random responders, it doesn't really seem to have much of an impact. Right? Our regression, our correlation is not really affected all that much. And I think a lot of researchers who maybe encounter random responding think that this is what's happening in their data. Yes, we've got a little bit of noise there, not a big deal, it's better if we don't have it, but it's not a huge problem for us. What if you're measuring variables where most of the real responses are towards the low end? Right? Now you can imagine what happens. You add in your random responders and suddenly a effect that was perhaps 0 ends up being positive, perhaps strongly positive. And you don't need a whole lot of people there. It doesn't have to be like 50%. I wrote a paper back in 2010 showing that this happens quite convincingly with 5% of people answering carelessly or randomly. You can even go the other way, right? You can have a negative relationship in your real data. You add in the random responders and suddenly it's positive. So you can flip the sign. And again, you don't need many people for this to happen. So I wrote this paper back in 2010 showing that this can happen and reviewed some evidence that it does happen and some of the data that we had. And basically there were 3 variables that seem to drive this effect. The first one was simply the base rate, like how many people are answering randomly. 1% is better than 5%, 5% is better than 20%. The other thing that seemed to matter was the correlation in the non-random part of the sample. Right? If that's already positive, then having some random responses doesn't seem to make a huge difference. If it's negative, the effect is really large. And then also, how far away from the midpoint are those answers? Right? If they're really pulled far away in the bottom left-hand corner or the top right-hand corner or any of the corners, then this effect becomes much larger. And of course, we often study things where most people say, no, that's not me at all. Right? I have a friend who does a lot of stuff on like the dark triad. Right? If you ask people whether they have psychopathic tendencies, most people will tell you that they don't. And so we tend to have data in the corners, not all that infrequent. So my most recent interest was on, well, yes, there can be an effect on the correlations, but can it also produce artifactual moderation effects? Can it give us these interaction effects that have that are simply an artifact? And so, simple example here, consider the dependent variable self-reported violent interpersonal behavior. We'll take an independent variable of self-reported depression and a moderator of self-reported psychopathic tendencies. Right? Perhaps a dumb analysis, but let's play with it. And also set up the data so that the correlations between the 3 variables are, as we have up there, perhaps not unreasonable numbers. And we're also going to assume, just for demonstration here, that we've measured all of these variables on a scale of 1 to 7 using 10 items per construct. Pretty standard procedure for many researchers in psychology. All right. So if we simply simulate that data and run a regression analysis with an interaction term, we find no moderation effect, because that's the way we set up the data, right? We didn't have an interaction effect, so we shouldn't find one. Yay, we did it. So that's good. Now let's add in 20% of our sample as random. It's a pretty high number, but not uncommon, not unheard of. As I've mentioned earlier, 40% of one of our samples appears to be indistinguishable from random. And because of central limit theorem, we know that the average of 10 items answered on a scale of 1 to 7 will be 4. And the standard deviation is going to be 0.55. Let's add those numbers in. And now, if we rerun that analysis, the interaction term suddenly adds about 7% of variance, which in psychology, at least in IO psychology, is a really, really large interaction effect. The average, Herman Agunis did a review a couple years ago where he found the average interaction effect was 0.002, and that's in published top-tier journal articles. So this is about 50 times bigger. So this would be a very large interaction effect, and if somebody found this, they would get very excited and run off to their favorite IO journal and probably get this published. So what's really going on here? What we have on the y-axis is aggressive behavior, on the x-axis is depression, and what we're seeing in blue, those are the random responders, right? They appear to be unusually aggressive because they're simply answering randomly. They're saying, yeah, I like to beat up people, I'm super aggressive. And they're also indicating high levels of depression, again, because of their random responders. Right? They're not paying attention to the items. And then if you break that up into low and high levels of psychopathy, or psychopathic tendencies, you end up all the random responders on the high psychopathic tendencies panel in the top there, right? Because again, they're answering randomly to the psychopathic tendency measure. They all appear to have highly elevated measures of that. And of course, you can see quite nice slope differences there. And this is the kind of stuff that will get you published quite nicely in one of our top journals. So of course, that's simply a demonstration. What we wanted to do next was we wanted to simulate this a little bit, like to explore some of these factors. What could be driving this? And so we ran some Monte Carlo simulations, and we varied primarily the base rate of random responding in our data. We varied the distribution of random, non-random scores relative to the continuum. Are they clustered on the low or the high end? The correlations between the DB, IB, and moderator, right? The true correlations, we varied those. And then we've also varied the number of items in the scale. And this rapidly became a rather large Monte Carlo simulation. So we ended up basically with 324,000 unique combinations of these manipulated variables. And we ran 162 million simulated data sets, which took a while on some pretty powerful computers. Luckily, my collaborator works for the Army Research Institute, so he has access to some supercomputers where he could do this, but even that took about 20 days of running for us to get these results. So this literally reached me 3 or 4 days ago, so what I'm sharing with you now is pretty neat. So this is a very crude summary of what I'll show you in a second. If anybody's interested in seeing some really large pivot tables where you can explore any of these combinations, I'd be happy to show you. It was a little bit too much to attach as an email. But what I really want to focus on is, well, at least my attempt here, these are the type 1 error rates. Right? The type of basically coming to the incorrect conclusion about the presence of a moderator. And what we see here is that, for example, let me walk you through one of the simpler ones perhaps. This is the rate of random responding on the x-axis. So as soon as you get to about 5% random responding, you get to about an 80% type 1 error rate, almost immediately. And it gets a little bit higher for higher rates of random responding, but it flattens out pretty much very quickly. So 5% is enough to almost guarantee a type 1 error. Most of the other variables didn't have a huge influence on type 1 error rates. It really didn't matter how many items you had on the scale. It didn't matter how far they were shifted to the left or to the right. It didn't matter how the independent variable, dependent variable, and moderator were related to each other. It's simply a very, very low base rate of random responding will almost guarantee you to commit a type 1 error, that you incorrectly conclude the presence of a moderation effect. So that's simply the type 1 error rate. That gave me a heart attack when I saw it. I kind of expected something like this, but nothing quite as extreme as this. And then the next one is the size of these effects. And again, these are changes in R squared due to the interaction term. And again, you can see that most of these are in the range of about 6%, which may sound small, but in moderated multiple regression, an additional 6% attributed to the interaction term is actually really, really big, much bigger than what you typically see in the kind of journal articles that are published in this discipline, where people often get quite excited about a 1% increment in variance explained. So again, it didn't really matter what the specific characteristics were, so all these wonderful variables we manipulated that we thought would have a lower, they mattered to some degree, but the biggest thing was simply the base rate. As soon as you're at 5%, game over. Right? You're basically going to draw the inference of very large and substantial interaction effects. So the obvious question here is, well, do researchers in this discipline, do they monitor for random responding? It's actually not that difficult to at least catch most of these individuals. Right? You can look at the time that people take to respond in a survey. Right? If you're doing it online, you can capture that. You guys know all this. You can embed items that look at the consistency of responses. You can ask people, check C for this answer, and if they don't check C, you eliminate them. There's all sorts of things that you can do. But our kind of review of how research at least is reported indicates that almost nobody is doing this. We found a small handful of these many, many interaction articles that actually said we had some attention check items. We eliminated 8%, 20%, whatever it was, of our participant pool for failing that attention check. Almost nobody seems to be doing it. So to me, there's already this big chunk of results that are reported in our top journal, about 30% of our articles that are focusing on these moderation results. To me, looking at those results, I almost throw up my hands and say, I can't trust any of it. Again, especially because we don't have pre-registration. We don't know that these were hypotheses you actually came up with beforehand. I was once asked as a graduate student by a faculty member to run every possible interaction analysis I could in a data set. And it would have been hundreds of them, and I was smart enough at the time to say I wouldn't do it. But this faculty member didn't want to just look at the two-way interactions, but also all possible 3-, 4-, and 5-way interactions. I can't even interpret a 3-way interaction without getting a headache. But that would have made its way into the journal articles. A friend of mine recently reviewed a paper in which the paper was about a 5-way interaction. And you think, there was no way that was hypothesized, right? They dug through their data, they data mined, and they found something, and they wanted to get a paper out of it. So to me, when I say that we can safely and perhaps prudently ignore much of what's been written in this field, one of the reasons is exactly this. That this is so easy to find artifactually. So to conclude, if I had control over some of these top journals, what would I do? I think we need to return as a field much more to basic measurement issues. I think we still don't have a very good handle on how to measure some of the variables we're interested in. Better theory will help as well. And then also simply return back to basic experiments. We don't do those enough in IR psychology. We're largely based on observational data. Until we go back to that point, I think we're not going to advance very much. Also, I'd like to see much more replication. Social psychology has been really good about this. I'm not sure if any of you have read some of these many labs replication attempts, where they identify a single experimental effect or a test, and they have like 25 different labs from all over the world try to replicate them, and they report them all in one paper. They're incredible efforts, and they really, I think, advance social psychology and to pull them back from this kind of precipice they were on. And then also much more open science practices. And in social psychology and personality psychology, it's getting more and more difficult to publish without at least doing some of this. But it's not a requirement. And when you talk to editors, I was sat in the audience for an editor panel a couple of years ago at SciOp, and the editors were asked about whether they think there's a replication crisis in IR psychology. And the answer was almost uniformly, no, we don't have a problem. This will all be resolved using meta-analysis, which I'm not sure how that would address many of the problems that we found here. So I will conclude on that note and open it up to questions that people might have. We're around 3:45. Yes?
What would you say we could do as practitioners to solve the problem?
Make it clear that you're not happy. I think that's been a discussion that's been happening a little bit between academics and practitioners, but I think practitioners need to be louder in terms of saying this is not, you're no longer publishing things that you're interested in. Again, looking back at, like the Journal of Applied Psychology, I feel like if you go back to the 70s and 80s, they were publishing articles that were much shorter, but I think often much more relevant for practitioners, and less this sort of huge chunk of theory that has to accompany everything. I think that, I'm not sure how helpful that is to anybody. Even I think a lot of researchers aren't necessarily all that impressed by that, but somehow the editors have decided that that's how we have to write it. So, I don't know. Vote with your dollars and with your attention. And speak to your academic friends as much as possible.
Well, I mean, you see how what you have to say is absolutely right. I hope you see how that plays into Donald Trump's anti-intellectual narrative. Can't believe anything the academics say because they all lie.
I hope he's not paying attention to what I guess it would be nice if he was paying attention to what I was saying. But yeah, I mean, there is some truth to this issue, at least in this field, and I think that's why I literally used to make fun of social psychology. If I wanted my research methods students and undergraduate to understand how to not do research, I would get a social psychology article from Psych Science, and I would say, here's what's wrong with this field. And that was 6-7 years ago, and now they've turned the corner. I mean, there's still lots of questionable work being done there, but it's much cleaner. I mean, data is being reported, people are doing replications, stuff's being retracted, they're clearing house, and we're not doing it in IR psychology. So there may be, I think it's a more nuanced message than that, but I'm somewhat sympathetic to this view that, man, should we be paying attention? And some of our top journals have kind of felt it in terms of impact factor. Journal of Applied Psychology impact factor has been on a downward spiral for a couple of years now. Whether they'll recover is a different question.
For those of us outside of the academic space, do you think there's something that is incentivizing this bad behavior, or is it, like, what do you think some of the root causes are, other than maybe they take one research method class in undergrad?
So in my field, there's been this exodus, I think maybe dating 10, 20 years back, from psychology departments to business schools. And I feel some of it can be attributed to that. Business schools have a really heavy emphasis on theory, and so the requirement has been to always add to, or theoretically add to what's known. And the way to add theoretically to what's known is often to present really complicated analyses, to say, oh, we have a moderation effect, but that's basically a boundary condition, right? And yes, a good theory has boundaries, but we're complexifying these theories. We keep adding more and more modifiers to it, but that's what's being rewarded. And as I said, these financial incentives are enormous. If you write a straightforward experimental study, I think, and submit it to Academy of Management Journal, your chances of being published are pretty low. Whereas if you say there's some crazy curvilinear relationship between extroversion and sales performance, people like that story, and they go, oh, let's publish it. And that's exactly one of the, one article that was published in AMJ a while ago was describing this curvilinear relationship. And I've spoken to practitioners who have data on this issue, and they say they can't find it, right? And they've tried to publish the inability to replicate that one study. They have 10 samples where they don't find the curvilinear relationship, and the journal's not interested. Because failure to replicate is not as interesting as some sexy story about a moderator.
The comment I would make about the theory point you're making is that I agree with what you're saying, Marcus, but I think when I read a journal like Journal of Applied Psychology, the sort of attention to theory there, I wouldn't really call attention to theory. It's more like a half-hearted attempt at at least making it look like you're paying attention to theory. I wouldn't really I don't think anybody is actually seriously trying to advance theory or thinking about theory in any serious way. What they're doing is saying, I have to put something in here so that it looks like theoretical. That way I get this thing published.
Theory dust, you sprinkle over it. Post-hoc theory dust, And it's often the more complicated the model of it. If you can add a hierarchical component to it, even better, so you have people nested in teams or groups or departments, and you have a moderator and at least two mediators, then you're golden.
Well, I guess the point that's critical there is I would actually encourage people to pay more attention to theory, but just not in the way they're doing it, right? To actually take it seriously, not as an exercise.
Right, but actual good theory requires not only that you propose it coherently, but that you then also go out and test it. And not just test it once, because I think a theoretical proposition is there's a really high burden of proof there. And it's not just, in this one convenience sample I gathered at time one, where I may or may not have harked my way to something, you go out and replicate it 5 more times, and have other labs do the same thing, and then we can take it more seriously. I think some of the best theory work in psychology across domains has often been using having the data lead the way. Goal setting theory. By Locke and Latham, at least the way they describe it was that they gathered data for like 25 years before they ever sat down and said, we have a theoretical sense of how goals influence performance through motivation and through feedback and all these kind of mechanisms. But these days, I think the theory often comes very close to the data, often directly after it.
Are there any, because you're a reviewer for a lot of different journals, are there any journals that have a more rigorous process, or are thinking of moving towards a more rigorous process, or opening up to replicate?
As I said, Journal of Business and Psychology has been encouraging this for a while. A lot of the social and personality ones are pretty good about it. Some of the open source journals. And then outside of our discipline, we look bad in comparison to like economics. And I've been reviewing a fair amount like political science recently. And like opening up your data is standard practice. I believe judgment and decision making has for a long time now, when you submit your article, you have to submit your data set with it. So it's not just when it gets accepted, it's at the submission stage. So the reviewers can take a look and say, did you do the analysis correctly? Is it appropriate given your data assumptions? All those kind of things. And again, I'd like to see that happen. But I think there are institutional resistances. People don't want to do this because I sometimes wonder how our journals or the articles would change if we had that system in place. I am super cynical. I know that sometimes I feel like I sound very negative about this. I suspect that for many researchers in this field, not all, but many of them, what happens is they get permission to gather some data. and they say, how much time do we have? 45 minutes? Okay. I'm going to get as many constructs out of this as I possibly can. I'll figure it out what I want to test afterwards. And it's kind of understandable, right? Because it's so difficult to get access to data. If I'm working with a university subject pool, I can get 1,000, 1,500 participants a semester, not without much problem. It's almost impossible, for many of us, it's almost impossible to do that in organizational settings. So, and then you get your data, and perhaps your actual theory or the hypothesis you had doesn't pan out. First of all, report things that don't pan out, that would be valuable too, but you want to get something out of it, right? Your tenure clock is ticking, your dean's on your back, and so you pretend, or you convince yourself that you really anticipated this three-way interaction that you managed to find. So, yeah, it's a little bit depressing, I know. I really feel strongly, I mean, I love this field. I think these questions that we try to answer in this field are so important. Work is so important, predicting and understanding performance is so important, that these games that we're playing as a field are not helping anybody. And I sometimes ask fellow IO psychologists, like, what have we done in the last 20 years? What's been the advance? And they often typically don't have a very good answer. Because even a conditional reasoning test, that's often the answer, but that goes back to like 2001 now, so we're stretching and whether that's an advance is a whole different topic. But that's the one I often get. It's like, well, we have conditional reasoning tests. I'm like, yeah, but it's been a while. And there are some people who don't think they're all that great either. So if we're not making advances, either there's something wrong with us or the system that we're working in.
Okay, thanks.
more?
Oh, wait, one more. Sorry, go ahead.
So, are you the same Marcus that Brad Brummel would talk about?
Yes.
You know Brad?
I know Brad, yeah. He sat in the desk next to me in graduate school, yeah.
So I've heard that there's also issues with like the reliance on null hypothesis testing
Sure.
and just trying to achieve that p-value.
Right.
Do you see any way forward with different types of statistics? For a while, I was interested in Bayesian before I went back to school and on time, but do you
Right.
see benefits in maybe moving towards these different types of statistics that might provide better inferences?
I don't know enough about Bayesian approaches to really be able to comment coherently. I'm still a big advocate to go back to like really basic stuff like effect sizes. Like good designs and the reporting of effect sizes, I don't really care about p-values because I want to know whether an effect is even there. Like null effects are for me really interesting if it's based on a clean design. So I get upset about p-values as well. I have a student who's currently doing a big project on using z-curves, looking at the distribution of p-values within an entire literature, and there are some literatures where when you look at that, all the p-values are right between 0.04 and 0.05. That tells you something's really wrong with that field, because that's not where they should be, right? They should be much closer to 0 if the effects are real. So there are other techniques that we have. I think that the debate is useful, but I think I want to go back to the basics before we get too complicated.
For the benefits of the young folks in the room, this effect size stuff, this starts in agricultural research. You got field A and field B, you put the fertilizer A on field A and fertilizer B on field B, and you water field C this amount, and water field, and see if crops are any higher. That's called an effect size.
Yeah.
Pretty dramatic. It makes a difference if you're a farmer. That's where these statistics come from.
Right.
Agricultural research, which I think is pretty interesting. Don't you?
I've depressed everybody.
Thanks a lot, Marcus. We appreciate it. So.